Hi guys, today we're going to talk about how to determine the volume of a pyramid and a cone. So section 35-2, we're going to work our way through the evens like we typically would, and then you guys will be assigned the odds. So I'm going to work through just some concepts of what does it mean to talk about volume again, and some formulas, and then we'll walk through some of the different approaches to these. So when we talk about volume, I want you guys to think about a container, a 3D figure that we're going to fill with material. That's the concept of volume. So if you ever have filled up a cup, which I'm sure you have, or a bucket, or a bowl, or a bottle, like I'm literally sitting here looking at an empty water bottle, the amount of material that you are putting into that object, we want to think of that as volume. Volume is a three-dimensional measurement, so it's going to be units cubed. And so when we take a look at some of these examples, we're going to be focusing on two particular figures, the pyramid and the cone. So a pyramid's going to come to a nice point just like the cone, but the pyramid is going to have a different style base. So I'm going to scoot up my paper. You guys can take a look at 7 through 12. So you notice how the cone has the circular base, and then the pyramid has a different base. And be aware when I give you guys this assignment, we might be picking and choosing because some of the problems are a little bit more in-depth than we're going to be doing through our remote learning. Like I'm taking a look in particular at number 4. We haven't had the opportunity learning remotely to understand how to find the area of a regular hexagon, so we're not going to do that one. So just kind of bear with me as we pick and choose. So when we take a look at the concept of the volume of a pyramid, so volume for pyramid, the formula is actually pretty basic. It is, I'm going to use V for volume, 1/3 of, sorry I lost my train of thought, the area of the base times the height. So our task is to say, okay, if I were to have the point up on the top, what's it sitting on so that it doesn't tip over? Because we probably aren't going to take our pyramid and like try to put it point down and find the balance. We're going to set it down so that the point's on the top and it doesn't tip over. So when I look in particular at problem number 2, I'm looking right here at the base of a triangle. And that happens to be a right triangle. So I'm going to sketch that guy out, not perfectly done. So this guy is our base with 10 by 6 feet, and we're going to find that area. So remember, the area of a triangle is base times height divided by 2. So that gives us an area of 30. The height of our pyramid is this 15 because from where it's sitting, so it doesn't tip over, to the point, the vertex, that's our height. So we're going to take 1/3 the area of the base times the height. And we're going to type that into a calculator. This one isn't that difficult to type. 1/3 of 30 is 10. 10 times 15 is 150, and that would be feet cubed. And that's our very first volume problem. So I'm going to scoot on down, and we're going to take a look at problem number 6 together. Problem number 6, and I know that the hard part about doing some of this stuff is that we're trying to show a 3-dimensional shape on a 2-dimensional piece of paper, and trying to get that depth, that visual understanding, can be a little bit tricky. So kind of bear with me as we look at problem number 6. Whoever's playing with this shape, they kind of have it sitting on the vertex, and that's really not going to be very effective. It's going to tip over. So I'm really hoping that you guys can see that the base is right here as a rectangle, 6 by 8. So when we talk about our volume being 1/3 the area of the base times the height, that's why B is the capital B, we need to be thinking about the area of that base, which is 6 times 6 by 8. That's why I was using the X for the 6 by 8. So that's the area of the base. Now I need to switch over to my highlighter. We need to now identify the height. So from the center of that base, how tall? How far away is that? Well, we have this 5 yards sitting over here, and I'm going to kind of color code this a little bit. There's my yellow highlighter. We need to understand really what that 5 yards is. That 5 yards is the outside edge of that shape. It is not the actual height. In fact, this 5 yards is what we call the slant height. It's the height on the outside edge of the figure, not the interior height. Well, that's going to cause us a bit of a problem. So we need to figure out how to identify how high that guy is going to be. Well, we're going to, and I'm going to provide you guys some information. If this total distance is 6, this point right here is in the center of our shape, then we're going to split that into 3 by 3, cutting the 6 in half for the bottom of that triangle. When we think about how this is going to help us, guys, in terms of this triangle, we have 2 lengths and a right angle. We can do Pythagorean theorem. So I'm going to call this guy X. X is sitting right here. That is the height. If we take 3 squared plus x squared and set that equal to the slant height, because that's our hypotenuse, we can solve for the real height. And I hope this clears up here real soon. 3 squared is 9. 5 squared is 25. Please focus. Oh man. Oh man. Focus. Focus. There. So if we subtract off our 9, we'll have x squared equals 16. Take the square root. X is 4. That is the true height. So we had to use our knowledge of this shape and the slant height to find the true height. We need to multiply in our 4 for the height. So our volume, let's see, we are looking at 64 yards cubed. And you might be wondering, why is it a 1/3? If we think about cones and pyramids, if we wanted to build a rectangular prism, like a Kleenex box, it would take 3 of those cones or pyramids to create that full box or rectangular prism. That's why it's the 1/3. So on number 8, we're going to move forward and we're going to talk about the the volume of a cone. So think like ice cream cone. The ice cream would be sitting up here on the top. The volume for a cone is going to be equal to 1/3, hey, that looks kind of familiar, times pi r squared, and I'm going to put that guy in parentheses, times the true height from the center point to the vertex. Guys, this pi r squared is really truly the base. The volume for a pyramid or a cone is the same thing. It's just that on the cone, it's always going to be a circle, so it's pi r squared. So we're literally going to jump right through the hoops of this one. We're going to take 1/3 times pi. Our radius is 8 squared times our height of 10. I'm going to use 3.14 for pi. If you use your pi button on your calculator, you might get a slightly different answer in terms of our decimals. So we are looking at about, I'm just going to round it up to 670 feet cubed. Number 10, let's see if we can work our way through number 10. So when I'm looking at number 10, I see the whole diameter of 20 yards. So that means that our radius will be 10 to cut that in half. Now here, again, we need to find the height. But we've got a problem because our height has to be perpendicular from the vertex down to the base, which is that circle. Well, we have a slant height of 18. So I'm going to pull that little triangle out where it says 45 degrees there, 18, and I'm going to make my height x. A couple things to remember. If we have a 90-degree triangle and one of the angles is 45, the other angle has to be 45. It's isosceles, not drawn to scale. That means that this bottom is also x. Don't assume that's the radius, because this is not the center. Even I can see that, and I can't draw very well. So working with this triangle, knowing that it's isosceles, each one of these two sides is the same. So with Pythagorean theorem, we could say x squared plus x squared equals 18 squared. Well, that's 2x squareds, and we can start solving. Let's see, 18 squared is 324. I'm going to divide by 2. That gives us x squared equals 162, and now I'm going to pop through that square root. So we're looking at around 12.7 for x. That's not what we're seeking. That was the height. Remember the way that we're going to calculate our volume. It's going to be equal to 1/3 pi r, which is 10 squared, times the height of 12.7. And I know that's tiny, but I'm kind of out of room, so I'm going to maybe zoom in a little bit more so you guys can see those pieces. And then I'm literally going to start typing. I don't know if it's going to focus with my calculator in there or not. So there, you can see it. 3.14 times 10 squared times that 12.7-ish. And then I'm just going to divide by 3 because that's the same thing as multiplying by 1/3. And we are looking at 1,329.3. And that guy was yards cubed. Okay. So I'm hoping that helps. I may need to do some more examples for you, but those are kind of the basics of what we're playing with. I'll walk through number 12 with you. So notice that we don't have our radius. I know you can't notice it because you can't see it. It's blurry. Come on, autofocus, please. Please autofocus. There. But again, we know that these two sides are going to be the same because it's a 45, 45, 90 triangle. It's isosceles. They're going to match. So we could do x squared plus x squared equals 16 squared. And really our goal is to find this diameter, which also happens to be our height. Well, let's see. 16 squared is 256, and that's equal to 2x squared. If we divide by 2, that gives us 128, and then we're going to take the square root of that value, and x is 11.3-ish. So understand what that is. That's our height and our diameter. So that means that our radius will be 11.3 divided by 2, which is about 5.7. The more we round, the further away we get from what we want to have. So now we can actually find our volume, if this will clear up. So our volume, I don't give myself much room here, is 1/3 times pi times our radius squared times our height. And I'm coming up with about 384 centimeters cubed. If you round it a little bit differently, you're going to get some slightly different values, but I understand that. So hopefully that helps you guys. This video is going to be just about 15 minutes. Let me know if you need more help. This concept of finding that height from the vertex or the point of the cone or the pyramid coming straight down to the base perpendicular can be a little bit challenging. So let me know how I can support you guys with your learning. And then you guys need to make sure that you follow the directions on the assignment, because you might not be assigned all of the problems. I do want to take a quick look at number 9. You'll notice that the 30 is actually outside the shape. You'll notice it better if it will focus. Just because that's measured outside doesn't mean that it's any different than the length on the inside. So here's a quick hint. Number 9 does happen to have a height of 30 on that cone. Alright, I'm now at 15 minutes and 32, 33, 34 seconds. Take good care of yourselves. Bye.